Hi. As promised, this is the recording for the challenge question of tutorial 1. I'm going to share my screen first. Should be quite fast. Okay, so the challenge we have is we have now two non-empty sorted arrays, and I want to the output is the median of two sorted arrays. So, of course, one solution is we can just combine both arrays and there'll be a size of n plus n. And I take the median of the combined array. So that is one of the one approach. Right, what is this of the combined array? And that will be OM plus n time complexity. What we want to try to achieve is O log of m plus n, which means that we need to do a little bit of a search in order to achieve that. In total, there are 5 key insights that you will want to take note of. Okay, let's maybe make this a little bit bigger. The first insight is that if there is how we calculate the median. So if there are an even number of elements in the array, the median is the middle element together with the elements plus 1 divided by 2. So let's see if I have my OneNote is. So let's say if it is even and there are n elements here, is n divided by 2, n divided by 2 plus 1. And so the median will be n divided by 2 plus n divided by 2 plus 1 divided by 2. Okay. So rather x. So the element at n divided by 2 and the element at n divided by 2 plus 1, we take the average of these two. So if the number of even elements in the array. In the second scenario, if there are odd number of elements in the array, then the median is the center element. So if there are odd number of elements in the array, and it is odd, the median is x. So this will be n divided by 2, the ceiling. So it will be x. So let's say if it is 7, n divided by 2 is 3.5. The ceiling of this is equal to 4. So this is how we calculate median. So this is the first insight that that I want to share with you. The second insight is the following. The key thing is we want to partition the arrays into two parts. Everything on the left is going to be smaller or equals to everything on the right. So for simplicity, we will call the first array at the top x and the second array at the bottom y. So what we want to find is we want to find a partition such that all the blue boxes have values smaller than or equal to all the red boxes. And we also know that such a partition will definitely exist. Let's say if we arrange these boxes side by side, we get something that looks like this. We only want to focus, actually once we get this 4 boxes, right, we only need to focus on 4 elements in the boxes. And the 4 elements is on the X array, the left and the right of this, and on the Y array, the left and the right. So only these 4 elements, we only need to look at these 4 elements at any point of time. Let's say if we are able to find this partition. So we have not found this partition yet, but let's assume that we have found this partition. We are assured that the terminating condition will be the following, whereby this element is going to be smaller than equal than this element, and this element is going to be smaller than equal than this element. Okay, by default, we already know that this is smaller than this because the elements are sorted. By default, we also know that this is smaller than this because the elements are sorted as well. So the thing is, we want to find this partition such that after we carry out this partition, this number is also going to be smaller than this number, and this number is also going to be smaller than this number. So once we have found this partition that allows me to cut my arrays in this manner, it means that everything on my blue side is going to be smaller than or equal than everything on my red side. Okay, so this is a very important insight. Insight number 2. This is actually the key. This is actually the key thing in determining in solving this solution. Okay, so if you have trouble understanding this one, just pause it and maybe you listen again and try to digest this point. And this point is really the key. Note that if the number of elements in the combined array is odd, all the blue boxes, the whole one additional element than the red box. Okay, so this is a minor point, not minor but important point, because it will affect how it can how the algorithm going further forward. Okay, but this is really the key insight. This is the terminating condition that we want to achieve. Let's look at the next insight. Okay. If we are able to partition the array in this way, in this manner, then we will be able to calculate the median of this combined array using a combination of these 4 elements here. This follows on from insight number 2. Because if we can partition the array in this way, it means that we have found a way whereby the median would depend on all 4 of these elements together. Right now, we will find this formula, which we are taking from insight number 1. In insight number 1, we see that if the combined size is even, we take the average of these 2 elements. What we are doing over here is that this XL, YL, the maximum of this, we are looking to see whether which element XL or YL is going to come in this part. So this is either XL or YL. And this is going to be the maximum of either XL or YL. And here is the minimum of XR or YR, which in essence, right, we are actually finding which element should come over here. And naturally, we want to take the minimum of these 2. So when the combined size is even, what we are trying to find is we're trying to find the middle elements to take the median from. And the maximum of these two will give me the elements at n divided by 2. And the minimum of these two will give me the elements over here. If the combined size is odd, and as I shared earlier, if the combined size is odd, the blue boxes will hold one extra element than the red boxes. We just need to take the maximum of XL or YL, and that will be the median. Essentially, we are looking for, so it's either going to be XL or YL, and we take the maximum of it. Okay. So now the challenge is how to partition this array, or rather these two arrays. Okay. So that's the only challenge, which is of course quite difficult. Not so difficult. I mean, we need to understand how to do it. Okay? But at this point of time, we are really laying the groundwork. What is the median? What is the terminating condition? If we reach the terminating condition, how then do we calculate the median? So all these are the groundwork that we are laying down. Let's look at insight number 4. In the fourth insight, we only need to look at the shorter array. Okay? And we can infer where the partition is on the longer array. Okay, why I say that is because once we know where the partition is on the shorter array, we can infer where the partition is on the longer array, because the number of elements on both sides must be sort of equal, because we are looking at the median. So once we know that this is cut in, let's say if this is cut in, let's say like simplistically speaking, let's say this is cut in 4 elements and 6 elements, and then I have 20 elements here. So let's say there are 10 elements, there are 20 elements here. In all, there are 30 elements together. So the median will be the 15 and the 16 number. Okay. So let's assume that this is the situation. So if this is a situation and I have 4 numbers here already, then naturally I need to have 11 numbers here, and I need to have 19 numbers here, and I need to have 11 numbers here. Right? Let me see if I'm correct. No. I need to have sorry, 11 numbers here, and I need to have 9 numbers here. Sorry. Yeah. So because then that will make this side to have 15 elements, and this side to have 15 elements, so that both are balanced. So once I decide on my partition on my shorter array, I will be able to know how to partition my longer array. So what I really need to do is I need to just work on the shorter side and decide how do I partition this array. And the way we do it is we will take x start. Okay, sorry. So we initialize first the starting and ending of starting ending variable. And what we do is we do a so-called like a binary search. We search to find where this partition should be. And how we search is that we take the start and the end and we divide it by 2. So I believe at this point of time, let's do a little bit of a digression. Maybe when you were young, you have played this game like guess the number between 1 to 100. And Of course, there are many ways to guess that. So one of the ways is that I guess 1, 2, 3, then you tell me no, and go all the way to 100. Then yes. So that's one of the ways. Of course, there may be a slightly more efficient way of doing it, which is let's say I say like a middle number 50. Then you tell me, oh no, it's higher or lower. And then I will say higher. Okay, let's do 75. Higher or lower. And then we actually cut progressively by half every single time. So that is the more efficient way of doing, which we will cover later on in this course called a binary search. So what we are in fact doing right now is we are doing a binary search for the median, which is why we are doing the x start and the x end, and we are dividing it by 2, taking the floor of dividing by 2. Okay. And as we have seen earlier, the how to say the partition on the y array will be determined by the partition x array, and is given by this formula over here. Okay. There is a +1 here, but that is like a algorithmic implementation, because it works the math out a lot easier if you just insert the +1 there. So I hope this is clear up to now. Okay. If it's not clear, you can ask, but I think because it's recorded, so you can ask me now, but you can ask me later. So finally, we share our last insight. How do we shift the x start and x end? The first condition is the following. If xr is greater than yl, what this means is that there are too many values over here, and so I need to shift this partition to the left, conversely to the right, but shift this partition to the left. And how I do that is I will reduce my xn by partition -1. So this partition is not correct. I need to shift it one step to right, to my left. And this is an example of xr being bigger than yl. So evidently I need to shift this one to my left, because there are too many elements here already. There are too many elements here. I need to shift this one to my left. The second condition is, if this is not the case, I'll have to shift my partition to my right. It means there are too little elements here. I need to shift this to the right side. And how I do that is I will add 1 to my x start. And this is an example of how it looks like. How one of example of how we should be shifting to the right. It means that because there are too little elements here, I need to continue shifting this towards the right. Let's illustrate these 5 insights with an example. So let's say there are x and y, 1, 3, 5, 7, and 2, 4, 6, 8, 10. The length of x is 4, the length of y is 5. The first step that we do is we do an initialization. So we initialize x start to 0, x end to the length of x. Okay, this is the first thing. The second thing we do is then we iterate. As I shared earlier in my insight number 4, we iterate by doing a binary search. We search the x start, x end, and also from there we are able to find my partition of y. So I'm just applying the formulas here. I find my P partition of X and my partition of Y, and this is 2 and 3. I'm just using the formulas here. Okay. If I would extract out from my table, this is my X, Y, and X, L, and my X, R. YL and my YR. Let's look at this. This will take a little bit of getting used to. Partition of X is at 2. How we calculate this 2 is this is at 0.0, 0.1, 0.2. And so I get 3.5 over here. Partition of Y is 3, 0, 1, 2, 3, which is 6 and 8. And that's how I get 6 and 8 over here. Okay. Let's see. Let me check something. Okay. Visualization. I think I should write, maybe I should just write this. X start equals to 0, xn equals to length of X. I think that will make it a little bit clearer. Okay. Now we are at this part. So we come here. So now we compare between this condition. There are two conditions to find. Is XR greater than YL or not? XR greater than YL is false. Is false means that there are two little elements on this side. So I need to shift this to the right. And to shift this to the right, I shift X start equals to the partition plus 1. Okay. So this is the first iteration. In the second iteration, what happens is that I calculate my X start, which is partition X plus 1, which is 3. Xn doesn't change, it still equals to 4. My partition of X now is equals to X start plus Xn, floor divided by 2 floor, which is equals to 3. Partition of Y still is now equals to the number 2. So partition of X is 3, 0, 1, 2, 3, which is 5 and 7. Partition of Y 0, 1, 2, 4, 6, 4, 6. And at this point of time, this is more than this, and hence we have reached the terminating condition. And in the final step, the number of elements in the combined array is odd, and so the median is the maximum of this two. And that is how we solve this problem. Thank you so much.